Find the area enclosed by the curve r is equal to 3 cosine of 2 theta. Area is equal to 1/2 integral from the alpha to the beta of the function 3 cosine 2 theta squared d theta. So to look in our graphing calculator what that looks like, we can see as we trace along, to trace the entire polar curve, we're going from 0 to 2 pi. So the alpha is equal to 0 and beta is equal to 2 pi. So we have 1/2 the integral from 0 to 2 pi of 9 cosine squared 2 theta. So we have 9/2 integral from 0 to 2 pi, and then using the double angle formula, we have cosine squared of theta is equal to cosine of 2 theta plus 1 all over 2. So we have 1/2 cosine of 4 theta, since theta was a 2 theta, plus 1/2 d theta. So that's 9/2. The integral is going to be 1/8 sine of 4 theta using u substitution plus 1/2 theta. Then following the fundamental theorem of calculus, replacing in the 2 pi, and then subtract replacing in 0. And then we get calculating to get 9/2. 0 plus pi, take away 0, which is 9/2 pi. Then finding the area by the curve r is equal to 4 sine of 3 theta. Looking at area is equal to 1/2 the integral from 0 to pi of 4 sine 3 theta quantity squared d theta. You can see that from our graphing calculators. We sketch this out, trace along, you see we go from 0 to pi. So we have 1/2 integral from 0 to pi of 16 sine squared 3 theta d theta. So to go to the double angle formula for cosine, solving for sine squared of theta, we get 1 minus cosine of 2 theta all over 2 is sine squared theta. So factoring out the 16 to get 8, integral from 0 to pi of 1/2 minus 1/2 cosine of 6 theta, since theta was a 3 theta. Then anti-deriving to get 1/2 theta minus 1/12 sine of 6 theta from 0 to pi. Following fundamental theorem of calculus, replacing in the value of pi. Subtract replacing in the value of 0. And then simplifying to get the answer of 4 pi. The next problem, we just need to set up the integral to find the area inside the polar curve. So our function, which is r is equal to 2 plus 4 sine theta. When you graph 2 plus 4 sine theta, you can see we have an inner loop and an outer loop. So we have the big loop minus the inner loop. You can see the area traces over itself, so we have an inner loop laying on top of the outer loop. So to just find the area inside, we're going to need to subtract out that inner loop that replaces over the outer loop. So setting r equal to 0, solving for theta to find out when the inner loop is created, we get theta is equal to 7 pi over 6 and 11 pi over 6. But the big loop actually begins at a negative pi over 6, which is the same as 11 pi over 6, but starting off in the negative direction. So we're going to integral from negative pi over 6 until 7 pi over 6. Of the radius squared d theta, minus, and then the inner loop is created from 7 pi over 6 until 11 pi over 6, again, of that radius squared d theta.